6.1 Measures of Central Tendency. So we're going to review a few of these measures of central tendency, and a lot of these you've seen maybe in the past from elementary school, but now they're a little bit more complex when we talk about these same concepts in this course. So the first measure of central tendency is the mean average. So this is the sum of the values in a set of data divided by the number of values in that set. So there's two types of means. We have a population mean and a sample mean. So a sample mean will be the approximate value of the actual mean of the population, whereas the population mean is the actual mean value of every member of your population. So when we talk about population mean, we're going to use a new symbol for that, and that is going to be the Greek letter mu that you see here. And for the sample mean, we're going to use x bar. We read it as x bar, so the x with a bar on top, to represent our sample mean. Now, the calculations for each are pretty much the same, which you just take every single value in your data set, you add them up, and you divide by the number of values. So the difference would be for population, you're using all the values that are in your population, whereas a sample only represents a small amount of values from your population. For data that's in intervals, such as grouped data, what you'd have to do is multiply the midpoint of every interval multiplied by the frequency of every interval and divide by the sum of all the frequencies. And I'll show you some examples on what that looks like. And then we have also the weighted mean, which is just like the way we calculate your marks. Take every single value and you multiply by its weight, and you divide by the sum of all the weights. And again, there's an example in this lesson that will show you how that works. We have medians as another measure of central tendency, which is the middle value when you rank your values from highest to lowest, or actually rather lowest to highest. So if there is an even number of data, I think this might be a little bit of a mistake here. So if there's an even number of data, then the median is the average of the two middle values. The mode is the value which occurs most frequently, and some distributions have more than one mode, and others have no mode at all. Outlier. So there are values that are significantly distant from the majority of the data, some that skew the distribution. So if you have, let's say, a series of marks in a class, well, most students would maybe score around whatever the average is, whether maybe it's a high 60 or low 70, but there might be some students who don't show up to class and have a very, very low mark. Those would be outliers. So here in a perfectly symmetric distribution, maybe most of the marks would be around the same. The mean, median, and mode would be around the same value, okay, and then everyone else's marks would be around that. For a class that maybe has a lot more students scoring higher marks, and your median and mode might be a little bit higher than your average. And for students who may be scoring really, really low marks, maybe your median and mode would be lower on the lower end, below your class average. So same thing with any other kind of data. You can have outliers which either pull upward or pull downward your values. So let's look at our first example. So here we have two class sets of marks. What we're going to do first is we are going to rearrange. Well, I'm just going to go back 1 second here. So these graphs, there's one thing I wanted to point out, which I may not have pointed out in class. So is that the mean, it's reading down here, the negative directions and positive directions. So if you have an outlier, your mean value, you can look at it as the median and mode being higher than the mean, or you can say your mean value is being pulled down by the outliers. Whereas over here, the mean value is being pulled up by the outliers if you have an outlier on the positive side. Over here, the mean value is being pulled down if you have outliers on the negative side. The curve of the graph still remains high for the mode, because remember, the mode represents the frequency of that graph. So which one's happening the most often? I just wanted to make that clear. So on the next page, example 1 here are sets of class marks. They're not sorted, right? So they're all over the place. So what you want to do is sort the data. So I'm going to sort the first set by place order. So from lowest to highest, this is what it's going to look like. So right here, 45, 51, 55, 64, 66, 68, 70, 71, 71, 71, 73, 76, 82, 83, 84, 90, and 95. For class B, you can also do this in rank order, meaning you don't have to take every single number and put them in order. You can simply rank your numbers from lowest to highest. So the lowest number here would be 12, so it'll be rank 1. 15 would be the next lowest number, rank 2. And here we would have 3, 50 would be 4. The fifth one would be 54. The sixth one would be 61. 61, again, and then 61 repeats, so that's number 7. Then over here I have 8. And 69 is 9. 73 is 10. And 74 is 11. 91 is 17. 80, sorry, 11. I'm just jumping ahead. Now 12 is going to be 75. And 13 is going to be 80. And if I fill in the rest of the numbers here, I already did this one, so I'm just going to fill in the rest of the numbers with it. So we get our rank. 18, this one's 15. And over here, 17 and 16. Okay, so we can rank our numbers from 1 to 18 because we have 18 numbers here. And I'll show you how we can find the median using a rank or looking at the data sorted in order. So calculations. Determine the mean, median, and mode for each class. So the mean for class A is equal to the sum of all the values divided by the number of values. And so that would be 45 plus 51. And instead of writing out all those numbers, I'll just put a dot, 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 and then my last number, and divide everything by 17. And when I do that, I get 1215 on the top divided by 17 on the bottom, leaving me with the mean value of 71.5. The median value, if you have 17 numbers here, the middle number will be the 9th value. And then so I'm going to just highlight the 9th value here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my 9th value, 71. Or, yeah, not sorry, just write 71. Okay, and how do I know it's the middle value? Well, you have to have exactly the same number of values on the left as you would on the right. So I have 1, 2, 3, 4, 5, 6, 7, 8 on the left, and 1, 2, 3, 4, 5, 6, 7, 8 values on the right. Okay. If your data set was not 17, 17 is an odd number, by the way, so you have exactly one middle value. But if you had 18 numbers, an even number of numbers, what you'd end up having would be 2 middle values. If you had 2 middle values, you have to take the average of both. Okay, so let's go back to my ink. There we go. And okay. So that's my median value. The median value is 71, so let's write that down. And our mode. The mode is the one that occurs most frequently. So if I look at my table here, the values that occur most frequently is the number 71. So 71, 71, and 71. So the mode is 71. For class B, the mean value, when I add up all the values, so the sum of all the x values divided by the number of values. So 12 plus 15 plus dot, 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 plus 92, all divided by 18. So 1159 divided by 18, which is 64.4. So the median value. So again, instead of putting them in order, I just rank them. So if you have 18 numbers, the two middle values are going to be the ninth value and the 10th value. So the ninth value is over here, 69, and the 10th value is over here right beside it, 73. So what I'm going to be doing is, so here median is the ninth plus the 10th value, and it's the average of those two values. So it's going to be 69 plus 73 divided by 2, and that's going to be 71. Now our mode. So our mode, the numbers that occur the most frequently are, it looks like here 61 over here and 61 repeat twice, and 80 over here and 80 repeat twice. So these two values, 61 and 80, are the most frequent values, and you're allowed to have two modes. So I can say here 61 and 80 are both our modes. Now, you've done some analysis, you've done some calculations here. So these are important measures of central tendency. Well, what's the point? Well, you do have to do a little bit of analysis as well. So let's look at what we see here. So if we look at class A, we have all three central tendency values pretty much the same, 71.5, 71, and 71. Class B, the values are a little bit also different, 64, 71, 61, and 80. So when you compare those average values, they are a little bit more volatile. Here in class A, they're a little bit more consistent. So there's probably less variability. Most of the marks are around these values. Whereas over here in class B, the marks are chances are the marks are all over the place. You can also notice that class A has a higher average than class B. So I'm going to make a note of this. So class A, number one. Class A's average is higher than class B. But you notice the medians, they are the same. But the medians are the same. And my second point is going to be the measures of central tendency. Are similar. Class A. So they're all close to each other. They're all around that 71 value, but not for class B. Okay. And this suggests more variability for class B. Okay. All right. So what about outliers? So what is the effect of any outliers on the mean and the median? So the thing is with class B, if you look at class B, we do have some outliers. We have the 15 and 12. These two values are way below the average or the median value. So these outliers are actually gonna bring the average down. So I'm gonna say here the outliers in class B are causing a left skewed distribution. So what you're going to get is something like this: outliers that bring your mean average down. So without the outliers, what would happen to your mean? Well, your mean would go up, right? So without the outliers, what would happen to your mean? So the mean value x bar would be 1132. So if you add up all those numbers again without the 15 and the 12, you'll get this value here, so 70.8. So which is much closer to 71, which is what class A had. And it's also close to the median, which is also 71. So one other thing we can note here is look at the sample size. We only have a class of 18 students. So since the sample size is so small, there is a much greater impact from the outliers. So the outliers have a greater impact. Have a greater effect on the distribution. So often why you see something on your report cards that says median instead of mean average, because it the median tends to be a better measure of central tendency for smaller sets, right? It will uh, it sort of kind of filters out the outliers, and it doesn't contribute to having a great impact over on the average. All right, so I'm going to stop the video here, and I'll make this second two examples in a second video, and watch out for that video.